So today we are going to learn normalized difference built-up index using Landsat data. So if you want to learn regarding specific satellite data, then you can just leave the comments in comment section. And at first I have uploaded my shape file. So let's click on that. So this is my study area shape file, which is basically Hyderabad city located in India. So if you want to know how to upload it shape file in Google Earth Engine, then just tell me. I will make a tutorial how to upload shape file in Google Earth Engine. Okay. So then just this data set I have used in this tutorial. So just click on that. Data set availability is 2013, and this is the collection snippet. Description is over there, and bands SRB1, SRB2, SRB3. So band set is over their total band, and then image properties and term of uses. So if you want to know regarding this Landsat 8 level 2 collection 2 tier 1 data, then you can just Google it. So I have already opened. So this is the dataset availability or description about dataset. So revisit interval is 16 day, and then look at that the pixel size is 30 meter, and the band name and unit and minimum value, maximum value, and scale factor is over there. So if you convert this one, okay, then you will find the exact scale factor, and the offset value is minus 0.2, and pixel size is meter, and wavelength, which wavelength is basically used. So like a SRB1 band 1 is basically coastal aerosol and ultra blue. So wavelength is 0.4352 to 0.451. Okay, and then the band 2 is 0.52 to 0.512. This is basically blue band. Okay, coastal band and blue band, green band, red band, near infrared band, and similarly there is other band. Okay, so this is the basic sample code they provided. Okay, and image properties is over there, and then term of uses. Okay, so you can see the USGS visual identity system guidance. Like if you want to click over there, you will find it's loading. Look at that, USGS visual identity system. Okay, so if you want to know more regarding this data set, then you can visit this website. Okay, so over there is SM550.1 USGS visual identity system, and copyright and credit for using USGS photos and images as well as the others kind of thing. So in this tutorial I am going to use 2020. Okay, so this is my start date. You can increase or decrease your start date as per your need, and this is my end date and the same year. Okay, 2020, and then for function for the cloud mask using QA pixel white. Okay, so basically algorithm for Google Earth Engine QA pixel. So function is like that, function mask L8 S bar images. Okay, and then QA pixel cloud pixel. Okay, so you need to define the cloud shadow, like a this is the four number is cloud shadow. Okay, and B3 is a cloud. Okay, which, so in this video we are used basically less clouds that I have defined in this code. Okay, so if you want to know more, then I can explain in the next video. Okay, and then it's basically scale reflectance bands. Okay, so these are the bands I need to visualize for this tutorial, but I have told you in the earlier video. So what is the scale factor? Okay, so this is the basically scale factor. If you convert it, it will be 0.0000275. Okay, and then add the offset value minus 0.2. Okay, and then just return to the like a mask, cloud and shadow that I have defined over there. Okay, sorry, that I have defined over there for mask the shadow and clouds in these images, and then add the scale reflectance bands over there using applying scaling factor and offset value, and then mask the images. Okay, mask the images. So I'm just mask the images on optical band. Okay, that I have defined over there, optical band. So I need b2, b3, b4, b5 and b6, and then multiply with the scale factor and add the offset factor as per as the they have predefined in this level 2 collection 2 tier 1 data. Okay, and then NDBI. So NDBI is basically stand for Normalized Difference Built-up Index. So to calculate the Normalized Difference Built-up Index, we need basically B6 and B5. So B6 and B5. Okay, so B6 is a short wave infrared one band and B5 is the near infrared band. So okay, so these two band 5 and band 6 is very helpful to calculate the Normalized Difference Built-up Index. So that is why directly I have calculated, because I have already imported the band over there using scaling factor and offset value, and then just simply I need to calculate the NDBI using this one line code. Okay, so if you want to calculate any indices, then you have to write like that: image dot normalized difference band 6 and band 5, rename it as a NDBI, Normalized Difference Built-up Index, and return images add band NDBI. Okay, so this band I am going to add using this formula. This is the basic code you need to write. Okay, and then let's add the images, which images I am going to use for the calculation of NDBI. Okay, so I have told you. So over there, just click on that. You will see each and everything is about there. So from the collection snippet, I'm just copy these things and then paste it over there, and then filter bound means I want to just calculate for my start area, and then filter date. I have already defined my start date and end date, sorry. Okay, and then map mask ls bar, or which I have already predefined. Okay, this one, mask ls bar for cloud masking and shadow masking, and then add map add NDBI. Okay, so NDBI means this one. Okay, I have already calculated. Okay, add NDBI. So this code is right in the different way. So in the previous video, I have upload imported images, then I have cloud masking as well as the clip my study area, and then imported the band and then imported the indices. But in this video, I have calculated or defined each and everything, like imported the band as well as the calculated the NDBI as well as the start date, end date and cloud masking. Each and everything I have predefined. Okay, and then all of these things I have just masked with the help of this Landsat 8 data. Okay, and then just create an median composite This is the basic calculation code. NDBI mean LA dot select NDBI and median and clip. So and in that case you have to just clip your study area. So in my case study area is Hyderabad and I defined is a ROI. So that is why I need to clip my study area using ROI. Okay, ROI. So all of this thing is done. So let's move to the visualization part. So for visualization, at the same time you have to do the minimum value and maximum value. So we know any kind of indices value is range is from -1 to 0 1. So maybe in my case I defined it from -0.5 to maximum 0.7. And what will be the color? Gray, white, brown and red I have defined as per as my need. You can change it. And then map center objects. So in my earlier video I have write down this code beginning of the tutorial, beginning of the code, but in that case I have write it in the last. Okay. And then map add layer. So this NDBI median you have to add, and then just simply rename it as per as your name. And then export code is the similar to the other thing, like a export dot image to drive. Image is NDBI median. So NDBI median is these things, NDBI and median. And then sorry, and description is NDBI L8 CO2 as per as my need. I have write down it over there. And scale factor is 30 scale, and region is ROI, and max pixel is IE13. So the finally just run these things. It's a loading. It will take few moments on the basis of our internet speed. Look at that. The NDBI is loaded. So let's change the color. Look at that. Okay. Let's show you. So white portion is basically showing the low NDBI. Okay. This is the Hossein Sagar located in central Hyderabad. Look at that. So there is a very less NDBI. Less NDBI means there is no NDBI. It means very less built up index. So that is why it's showing like that. Another portion, look at that, the blue portion is very high NDBI. Okay. So this is the basically river. So this is the basically river, Munshi river. So in this river, look at that, the white pixel. It means there is a very less NDBI. Okay. So this is the basic or simple, very simple video or tutorial. So if you have any question regarding calculation NDBI using any satellite data like Landsat 1, 2, 3, 4 or 5, 7, 8 or 9, or using Sentinel-2 data, so just leave the comments. Thank you very much.